Okay. Good morning, all. In last class, we have discussed about header linked list. This is a special kind of linked list which contains a special node called header node at the beginning of the list. Now, there are two types of header linked list. Those are the first one is grounder header linked list, where the last node is going to contain a null pointer which indicates the end of the linked list. And the second type of header linked list is the circular header linked list, where the last node of the list points back to the header node. uh, in this figure you can see this, the last node is going to point back to the first header node of your linked list, and this type of header linked list is called as circular header list. And for both, we have seen the conditions for checking whether you have reached the end of the linked list or not. Okay, for the grounder header linked list, for checking whether you have reached the end node or not, we are checking this condition: temp arrow link is equals to null. And for circular header list, this is the condition we need to check, that is temp arrow link is equals to header. After that, we have discussed about the doubly linked list. We have seen that what is meant by doubly linked list, where it is a list, it is a list of linear collection of nodes, where each node is going to be divided into three parts: information, left link, and R link. Now, information field contains the data or the information to be stored. Then L link stores the address of the previous node or the left node, and R link contains the address of the next node or the right node. Okay, these are the fields of doubly linked list. After that, we have seen how the node can be represented. This is a structure of a node in a doubly linked list, where you have three fields: L link, data, and R link. L link points to the address of the previous node, R link points to the address of next node, and this data part is used to store the information. And we have seen this example doubly linked list, where which consists of four different nodes. Now, if you consider the first node, its left link contains a null value because there is no previous node for the first node, and similarly there is no next node for the last node, hence its a right link contains a null value. Okay, this is how we can represent a doubly linked list. And we have as that of your singly linked list, here also we are having a start pointer which points at the beginning of a doubly linked list. Okay, then we have seen the node structure which can be used for representing a node of a doubly linked list. This is the structure we are going to use for representing a node of a doubly linked list. Now, this node structure consists of one integer field data and two pointer fields R link and L link. Okay, then we have type defined this structure, that is type def struct node star a node, and then you have created one pointer called start, and you have initialized it to null, which indicates that you have created a empty doubly linked list. Okay, struct pointing to null means it is an empty doubly linked list. Now, next we have seen how to create a doubly linked list. uh, I think this algorithm we have studied. Now, step 1 is to create a node using malloc function. Then step 2 is to store the data into node. Then step 3 is to store the null values in both the links, R link as well as L link. Then the next concept we are going to discuss today is about inserting into a doubly linked list. Now, how we can insert the elements into a doubly linked list. Now, there are three positions where you can insert a new node in a doubly linked list. That is, insert at front of the list, insert at end of the list, and insert at a specified position in the list. Now, these are the three positions where we can insert the new node in the list. Now, let us discuss these three positions one by one. First, we will discuss about insert at front of the doubly linked list. Now, this is an algorithm. Now, the first and second step remains same for all three positions. That is, first step is to create a new node. by using a malloc function, that is temp is equals to struct node star malloc size of struct node. It is going to allocate a memory for a new node, and that memory is going to be pointed by a temp pointer. Then step 2, store the data into the temp node. That is nothing but you're going to store the value which you want to store in that particular node, that is temp arrow data is equals to value. Now the step 3 is store the address of the first node in temp nodes r link and store the null in temp nodes l link. Now to illustrate this, let us consider this example. Now this is a previous linked list which consists of 3 elements 10, 20, 30. Now in this linked list I want to insert a new node. We have created this new node called temp, and this is going to be inserted at the front of the linked list. Means before this start you should place this new node. For that, what I should do, now this new node's temp, the new node is temp arrow r link should contain the address of first node, which is nothing but the start. Means temp arrow r link should be start, and start's left link should contain the address of this temp, because this is two-way linked list. One way is from temp to start, and second way is from start to temp. Hence temp arrow r link should contain start, and start arrow left link should contain the temp. And then you can move the start to the temp, because after inserting this node the first node will be this one, hence we need to move the start to the node 40. Now same thing is given in this algorithm, that is store the address of first node in the temp nodes r link and store null value in the temp nodes left link, then store temp in start arrow l. Temp arrow r link is equals to start, temp arrow l link is equals to null, because temp will be the first node, hence its left link should contain a null value because there is no previous node for this temp. Then start arrow l link is equals to temp. Okay, these are the assignments we need to make. After that you need to shift the start to the new node or new starting node, that is temp. New temp, now temp becomes the start node, that's why you assign start is equals to temp, and finally you increment the count of the list, because after inserting the new node the number of elements are going to be increased by 1. Then finally you end the algorithm. This is an algorithm to insert the new node at the beginning of a doubly linked list. Okay, now for the C function we are going to have a program, that is experiment number 8 in your DSA lab. While discussing that, we will discuss the C functions for the inserting the element at the front of the doubly linked list. Okay. Now the second position where you can insert the node in the doubly linked list is at the end of the doubly linked list. Again, for inserting the node at the end of the doubly linked list, the first two steps are same. First step is to create a node using malloc, that is temp is equals to struct node star malloc size of struct node, and the second step is store the data in the temp node and assign null values at r link and left link. Okay, temp arrow data is equals to some value you are going to store, and you have initialized r link and l link to null. Now the step 3 is to check whether if doubly linked list is empty. If the doubly linked list is empty, then whatever the node you are going to insert, that will be the first node. Hence you just assign the start is equals to temp. Okay, if the doubly linked list is empty and you are inserting the node, means that will be the first node, hence the start should point at that particular node, and that's why we are assigning start is equals to temp. Okay, this is the case when the list is empty. If the list is not empty, then what you should do to insert the node at the end of the linked list. Now let us see this example. Now you have 3 nodes. I want to insert the fourth node, that is temp at the end of the list. End of the list means after this node 30, this new node has to be inserted. Now this is the scenario. Now you have stored the null values in left link and R link, and you have stored the data as 40. Now what I should do, now you should traverse to the end of the previous linked list. That is, we need to traverse to the node, the last node of the list. Now this is the last node of your linked list. Now I should have a pointer at this particular last node. Assume that that pointer is current here. That pointer is current. Now I should insert this new node after this current node. Now what links I should form? The current arrow, this is R link. Current arrow R link should contain the address of temp, and temp arrow L link should contain the address of current. Current arrow R link should contain the address of temp, and temp arrow L link should contain the address of current. Now this is how we can insert the new node at the last at the end of the linked list. Now how to traverse to the last node? Just use current is equals to start, means you initialize the current pointer at the beginning of the linked list, then go on moving the current pointer towards the right side until you reach the last node. Now this is the while loop which is set it for that purpose. While current arrow R link is not equal to null, you move the current to the current arrow R link, means you are going to move the current pointer towards right side until it reaches the last node of a linked list. Okay, like this the current is going to be placed at the last node. After that, now link the new node, that is temp node, to the last node of the list. That is, current arrow R link is equals to temp, then temp arrow L link is equals to current. Okay, this is how we can link the new node at the end of the linked list. Then step 6 is increment the count of nodes in the linked list. Then step 7 is exit. Now this is an example which you have already seen. Now the next position where you can insert the element is at inserting at a specified position. Now again, the user can specify the position by using two different ways. Either he can specify the node number at which he wants to insert the new node, or he can specify the key data after which the new node is to be inserted. Now here we are going to choose the second option. The user is going to enter the value, then you need to insert the new node after the node whose value is entered by the particular user. Now the first two steps are same. Step 1, create a new node, that is by using malloc function. Then step 2, store the data in the new node. Okay, then the step 3. Now let us see the example first. Now this is the scenario. Now you have three nodes 10, 20, 30, and I want to insert this new node called temp, that is 40, and the key value which is entered by the user is 20, means after the node whose value is 20, the new node has to be inserted. Means where this new node is to be inserted? Between 20 and 30. Between 20 and 30, a new node 40 has to be inserted. Now if I want to insert this new node 40 in between 20 and 30, I should have pointers at this particular node 20 and at a node 30, and you already have a pointer at a new node, that is temp. Assume that you have a pointer at previous node called current, and you have a pointer called next at the next node in the list. Then what address assignments I should make? The current arrow R link should contain a value of temp, then temp arrow left link should contain the value of current, and temp arrow R link should contain the value of next, and next arrow left link should contain the value of temp. then only it is possible to insert this new node at this particular position. Now how many address assignments you need to make? 1, 2, 3, 4 address assignments you need to make. Now let us see how we can write in the form of algorithm. Okay. Now first of all we should traverse till the data of the node after which new node is to be inserted. Then after that you need to mark the next node. Now to traverse to the node after which the new data is to be inserted, you take one temporary pointer current, initialize it with the start, and then you keep on moving the current pointer to the right side until current arrow data is not equal to the value which is entered by the user. Until this condition is true, you should keep moving the current to the right side. Once it condition becomes true, it is going to come out of the loop. Means after coming out of the loop, where this current is going to be placed, it is going to be placed the node after which the new value is to be inserted. And then one more pointer which is required, that is a next pointer which should point the next node in the linked list. That's why I will assign next is equals to current arrow r link. Current arrow r link. Now you have moved the two pointers, that is current and the next, at the appropriate positions. Now the next thing is to link the new node. Now for linking the new node, you should make 4 address assignments. Now these are the 4 address assignments. Current arrow r link is equals to temp arrow l link is equals to current, temp arrow r link is equals to next arrow l link is equals to temp. Okay, these are the 4 links we should form to insert a new node in between the two nodes of a particular linked list. Okay, then the step 6 is to increase the count of the node by 1, that is increment the count of the list by 1, and step 7 is exit. Okay, this is about insert operation, where we have seen the 3 different positions where we can insert the new element, that is inserting at front, inserting at end, and inserting at a specified position. Now the next operation which can be performed on a doubly linked list is deleting from a doubly linked list. Doubly linked list. We are going to delete a node from a doubly linked list, and it can be done with it can be done with the 3 different positions of a doubly linked list. That is, delete from the front of the doubly linked list, delete from end of the doubly linked list, and the third position is delete from a specified position of a doubly linked list. Okay, these are the 3 positions from which you can delete the elements of a doubly linked list. Now let us see these one by one. Now the first one is delete from front of a doubly linked list. Now consider this linked list 10, 20, 30. Now which node is going to be deleted in these 3 nodes? If I want to delete from the front, the first node is going to be deleted, that is a node 10, which is pointed by this start. Now after deleting this node, which will be the starting node of the new list, this one, hence we should move the start to this next node. Before that, you should free up the memory allocated for this node. Hence what we will do, we will place one pointer at this node and one more pointer as this node. Okay, at node 10 we will place a current pointer, and at the next node we will place a pointer called next. And what we will do, we will assign start is equals to next, means the start is going to be moved to the next node, and after that we are going to free the memory which is pointed by this current pointer, so that the memory is going to be released. After deleting this node, these are the two nodes which are remaining in the newly formed linked list, that is 20 and 30, and the start is going to point at from node 20. Now let us see the okay. Now the second position from where you can delete the element is from end of the linked list. Okay, now let us see the scenario. Now these are the three nodes 10, 20, 30. Now I want to delete a node from the end of the linked list, and that in that situation what I should do, which node is going to be deleted? Node 30 is going to be deleted from the list. Hence what I should do, you should have a pointer at this node 30, as well as you should have a pointer uh, before you should have a pointer the node which comes before this particular node. Means at this node you should have a pointer. Now what we'll do, we'll place one pointer called current at this node, and we'll place another pointer called next at the node to be deleted. Now what I'll do, I will just assign current arrow left link is equals to null. Means I am going to break this link. I'm going to break this link, that is current arrow left link is equals to null. Means this link is broken. Then next arrow L link should be null, so that both the links are broken now. Now this will be the last node, hence it is initialized to null here. And after breaking this link, there is no link between this node 20 and 30. Now, but you have a pointer called next, which is pointing at this node 30. Now, the next step is to free the memory allocated for this new node, which is pointed by next. That is free next means it is going to delete this node permanently, so that this will be the remaining link, which consists only two elements. Okay. Now, the next positions from which you can from where you can delete the element is from specified position. Now, this is an algorithm for deleting a node at a specified position. Now, before going to algorithm, we'll see the scenario. Now, this is a linked list. Now, the user is specified the value as 30. Means we need to delete a node whose value is 30. Whose value is 30 means which node is going to be deleted? This particular node. Now to delete this particular node, you should have a pointer at this node, at the previous node, and at the next node, because this node is connected to previous node as well as the next node. Hence, we are going to have we are going to assign new addresses for previous node and next node. That's why we should have pointers at previous node, current node, and next node. And then how we can delete this current node? Now, first of all, you should break the links. Break this link, break this link. Okay, and then by assigning null values in all these fields. Now, after that, you should have a links between this previous node and next. That's why previous arrow R link should contain next. Next arrow left link should contain previous. These are the two address assignments we should make to connect these two. Then after that, this will be the new linked list, which consists of only three elements 10, 20, 40. Now let us see the algorithm. Delete from a specified position. Now the step one is to read the data of the node, which node has to be deleted. That is nothing but read the value of a particular node which you want to delete. Then step two, traverse till one node before the deleting node. Means you have to traverse till one node before the node to be deleted, that is current. That is, for that you just assign current arrow r link arrow data is not equal to value. Now why you are using current arrow r link arrow data? Why not current arrow data? Because we need to traverse to the node which is to be deleted, one node before the node to be deleted. That's why we are going to check like this. Current arrow r link arrow data not equal to value. You keep moving. Current is equals to current arrow r link. Just one mistake is here. Just they have written link here. You just make it as r link. Current is equals to current arrow r link. Okay, then step 3, you need to mark the previous and next node. Now we have a node, you need to move the, you need to mark the previous as well as the next node for the node which is to be deleted. Now previous is equals to the current node, isn't it? And the current node will be current node arrow r link. Current will be the node which is to be deleted. Current will be current arrow r link. Then next is equals to current arrow r link, means this is the next node after the node which is to be deleted. Then this is the next node to the node which is to be deleted. Okay, now you have placed the 3 pointers. Now the step 4 is to, now current is pointing to the node to be deleted, hence delink the current node and link the previous and next node of the existing w link. Now previous arrow r link is equals to next arrow l link is equals to previous, and current arrow r link is equals to current arrow left link is equals to null, means the node which is to be deleted, for that node we are going to assign null values for the right link as well as left link. Then finally you print the data or the node which is deleted, that is print current arrow data. And one more thing you need to do here, that is you need to free up the space for which is allocated for this pointer current, that is free current. You just add one more statement here, that is free current. After that decrement the count of the doubly linked list, because you have deleted one node, hence the number of nodes are going to be reduced by 1, hence decrement the count of the doubly linked list by 1, and you the step 6 is end. Okay, now these are the positions where you can delete the element from the doubly linked list. Now we have discussed two different operations on a doubly linked list, that is insert and delete. Now the next operation which can be performed on a doubly linked list is traversing the list. As I told you, there are two main purposes for traversing the doubly linked list. One is for displaying all the elements of a doubly linked list, and second one is searching a node in the doubly linked list. Now these are the two operations for which we need to traverse the doubly linked list. Okay, now first we'll see how to display the elements of a doubly linked list. Now in singly linked list we have displayed the elements in forward direction, because it was called as one-way linked list, and so we have only displayed the elements in forward direction. But that in doubly linked list it is called as two-way linked list, means you can display the elements in forward direction as well as in backward directions. This is the main advantage of doubly linked list over your singly linked list. You can traverse in forward direction also and in reverse or backward direction also. Now let us see to traverse in forward direction we are going to use R link, and to traverse in reverse direction or in backward direction we are going to use the left link of your doubly linked list field. Now assume that this is your linked list which consists of 4 elements. If I want to traverse in forward direction, I am going to use R links, so that I am going to find out the next node in the linked list. And if I want to traverse in reverse direction, then I am going to use the left link. I will start from this last node and I will keep on using the left link until the left link becomes null. I should print the elements. This is how you can display the elements of a doubly linked list, either in forward direction or in the backward direction. Then searching in a doubly linked list is also same. Either you can search in forward direction or in backward direction from the last. Okay, this is about the doubly linked list and its operations. If you have any doubts, you can ask. Any doubts? Hello? Yes, any doubts? Pooja?
No, sir. Hello?
Yes. Any doubts?
No, sir. Clear, sir.
Clear, sure.
Sir, little bit confused, sir.
Where?
Sir, about nodes.
Nodes.
Nodes, sir, about.
In which part?
Sir, after there are four different thing nodes, sir.
Four.
Different thing nodes.
I'm not getting you. Okay. You
Sir.
can call me or you can message me personally.
Okay, sir.
We'll see what is the problem. Okay. Anyone else?